Student, this is a mock test based on soil fertility, and in competitive examination generally many questions are asked from soil fertility portion. So, this test is very important from competition point of view. So, start the question number 1. Question 1 is temperate soils are not very fertile compared to tropical soils. So, here two things are very important. First question is asked about fertility, and second is comparison between temperate and tropical soil. So, we have to compare temperate and tropical soil with respect to soil fertility, and question is asked why temperate soil have low fertility. And the options low water holding capacity, less depth of soil, more erosion and less decomposition of organic matter. All these options are related with the organic matter, because water holding capacity is good, then nutrient supplying is more, because mass flow is more, diffusion is more. The less depth is related with the poor soil fertility, more depth, more nutrient availability, more erosion, more loss of nutrient. If less erosion, then more soil fertility, and less decomposition of organic matter. If organic matter is less decomposed, so low mineralization and less availability of nutrient, and related to less soil fertility. So, all these four are related with the soil fertility, but here comparison is between temperate and tropical soil. So, which phenomena does not occur in temperate soil, or we can say which phenomena is responsible for low fertility of soil. So, answer is less decomposition of organic matter. In temperate region, temperature is very low, that is why mineralization process is slow, and nutrients are released by mineralization process. That is why the soil fertility is low in temperate region, because of poor decomposition as a result of low temperature. Next question, old soils are less fertile due to. Old soils are actually subjected to weathering and leaching. It is very common phenomena, or because of this weathering, physical weathering, biological weathering, chemical weathering, nutrients are lost. Then high temperature or low temperature, it is not always that old soils are subjected to high temperature, maybe low temperature. It is not always that there is low precipitation, there may be high precipitation, and all these three occur in old soil region or not. It is not necessary that high temperature and low precipitation occur in old soil, but excessive weathering and leaching is occur, it is must in old soils, because old soils are subjected to this weathering. So, this is the correct answer, excessive weathering and leaching. Once there is weathering, there is leaching and loss of nutrient. Then which factor does not influence the formation of the soil? Actually, soil formation is a long process, and there is a formula of soil formation that CLORPT. CL means climate, O organism, R relief, CLORP parent material, and T is time. So, these factors are responsible for soil formation, and in this formula tillage operation is not there. Tillage operation, whatever zero tillage, minimum tillage, conventional tillage, reduced tillage, conservation tillage, these tillage operations do not influence soil formation. Soil formation, CL means climate, O organism, R relief, P parent material, and time are responsible. That is why in this question the answer is tillage operation. Now, which one is not true for fine textured soil? Fine textured soil actually are clay soil, rich in clay, high surface area, less EC, better soil fertility than the coarse textured soil. So, which means is not true, means which occur in clay soil. So, we should know about the fine textured soil. Actually, fine textured soil are clay soil, that is why first option is not correct. And because of fine textured, okay, surface area is very high, and these high surface area retain more nutrients, that is why contribute in fertility, and CEC is very high in fine textured soil. That is why the answer is less CEC. Fine textured soil have high CEC, that is why because of high CEC, high surface area retain more nutrient and contribute in soil fertility. This is the reason that fine textured soil are more fertile than coarse textured soil. Next, soil fertility adversely affected by tillage operation using heavy implement because of. When we use heavy tillage implements like harrow, plow, subsoiler, chisel plow, these implements, then soil fertility becomes poor. Soil fertility reduction occurs due to use of these implements. This is true, this statement is true. And what is the reason? Destruction of good soil structure, compaction of soil, reduction in aeration of soil. Actually, when there is a compaction, okay, heavy tillage have high weight, there is a more load, so there is a compaction because of heavy implement. That's why compaction of soil is correct answer. Then when there is a compaction, soil aggregation is disturbed, so destruction of good soil structure because of compaction and load. And when there is a compaction, destruction of soil structure, then particles become very close and then there is a reduction in aeration. And because of this, aeration is reduced, aggregation is reduced, okay, become poor. That's why fertility become poor. So answer is all of these. So when we use heavy implements, compaction, destruction of soil structure and reduction in soil porosity. Next is soil microorganisms improve the soil fertility as they help in. How soil microorganisms increase the fertility, soil fertility? Question may be asked in this way. So decomposition of organic matter, yes, they are involved in decomposition. That's why there is nutrient mineralization, release of nutrient. Maintenance of soil pH, reduction in the deployment of hard pan, all of these. So soil pH phenomena is high buffering phenomena, and soil pH cannot be changed very easily in soil. So microorganisms do not play role in soil pH. And hard pan is developed due to heavy implements, not by the microorganisms. That's why correct answer is decomposition of organic matter. When we apply organic matter, FYM or crop residue or any other biomass, then microorganisms act on this organic matter and they derive the carbon for their source of energy, synthesize their body, and during this process nutrients are released which were locked in organic matter, okay, and these nutrients then become free in soil and available to the plant. So this is the reason that microorganism increases the soil fertility. Next is the relationship between organic matter content and soil fertility is. So organic matter content is high, definitely soil fertility will be high, because if organic matter is high, then mineralization will be there and nutrient release will be there. So whenever organic matter is high, fertility is high because of more availability of nutrients. So that's why relationship is direct, not inverse. Inverse means opposite, okay, and direct in clay soil and inverse in sandy soil, direct in sandy soil and inverse in clay soil. It is not like that. Whenever organic matter is high, fertility definitely will be high, and it has no relationship with the soil texture type. So that's why answer is direct relationship. Then soil productivity is measured in terms of how we measure the soil productivity, okay. So quantity of available nutrients or quantity of total nutrients, biomass production, soil depth and density. Whenever we want to know what is the soil productivity, then we grow the crop and see how much yield is there. So that's why biomass production is indicator of soil productivity. While in case of soil fertility, availability of nutrient, how much nutrient is available, it is the index or parameter of soil fertility. But in case of soil productivity, measurement or parameter is crop yield or crop productivity or biomass production, we can say. Next is which one is genetic factor of soil productivity. Okay, so in case of genetic factor, it is soil texture. There are so many factors, but the genetic factor is soil texture, and this texture cannot be changed easily. Soil structure can be changed, soil aeration can be changed, soil reaction, pH can be changed by the addition of lime or any acidilating material, but soil texture cannot be changed. When it is formed, it remains as such, and it is genetic factor of soil productivity. Then potential micronutrients are, actually there are two types of nutrients, macronutrients whose requirement is more and micronutrient requirement is less. But there is another category which are known as potential micronutrients. These are beneficial for the plant and improve the growth, yield and quality, and these nutrients are known as potential micronutrients, okay, and these potential micronutrients are beneficial nutrient. For example, sodium, it is beneficial for saline condition, silicon for rice. These are the potential micronutrients and benefit the plant in certain condition and certain plants. Next is the tendency of some crop to absorb and accumulate nutrients far in excess of their actual need is termed. Actually, plants absorb the nutrient as per their requirement, but sometimes plant absorbs some nutrients more than its requirement, and their absorption is high. And this phenomena is called luxury consumption. Okay. In case of hidden hunger, there is a nutrient deficiency. Answer is luxury consumption, and it is very common in case of potassium. And in case of hidden hunger, there is a nutrient requirement for the plant, but plants do not show deficiency symptoms. When we apply the nutrient, there is a response, increase in yield, increase in growth, and this phenomenon is known as hidden hunger. Okay. And when their uptake is so high that it reduces the yield, then it is toxic uptake. But it is question is tendency of some crop to absorb and accumulate nutrients. In this question, nutrient is accumulating. Okay. There is no adverse effect, and this phenomena is luxury consumption, and this is very common for potassium. Plant usually absorb nitrogen more during. Okay. So, when plant requirement is high for the nutrient, when dry matter production is very high, whenever photosynthesis is high, dry matter production is high, then definitely nutrient demand will be very high, and this period is active growing period when shoot formation is taking very fast, leaf production is there, shoot formation is there, branch is there, tiller formation is there, and in this during this period nutrient requirement is more as compared to other stages. So, that is why nitrogen absorption, not nitrogen, other nutrients are also absorbed more during this period, so that photosynthesis can take place at a high rate and there more dry matter production. Next question is response to applied P depends on. Whenever we apply phosphorus, then how this absorption or utilization by the crop depends on soil property, whether it is clay, sandy, coarse texture, fine texture, variety, short duration, long duration, hybrid, composite, method of application, or we are applying split application or spot application, or we can say band application or broadcasting, or all of these. So, soil properties are very important, because in clay soil phosphorus get fixed. So, this question is related to phosphorus. So, in case of phosphorus application, soil properties are very important. In fine textured soil, clay is more and there is more binding of phosphorus with the clay and phosphorus get fixed. Then varieties, some varieties require more phosphorus because of more biomass production. For example, hybrids, in case of maize hybrid, more biomass production, more yield, that is why they require more phosphorus, and response is more at high dose of phosphorus. Whenever we apply low dose of phosphorus to hybrid, their biomass production or dry matter production is less. So, variety is important factor. Then method of application, when we apply the phosphorus as a broadcast, then it get mixed into the soil, and soil have capacity to fix. For example, in high pH soil, phosphorus get fixed with the calcium and magnesium, and in acidic soil, it get fixed with the iron and aluminum. So, method of application is very important. So, that is why we apply phosphorus in band for its get low fixation in soil. So, all these factors are very important for higher recovery of phosphorus. Leaching loss of potassium is more. So, whenever there is abundance of potassium in soil, there is a leaching, and which factor is responsible for more leaching? Soil type, clay soil, sandy loam soil, silty clay, sandy soil. So, which soil which have less CEC definitely will hold less potassium, and then leaching will be more. And in sandy soil, out of these, sandy soils have very low cation exchange capacity, and this is the reason that potassium leaching occur. Not only potassium leaching, other cations are also leached in sandy soil because of poor CEC, they cannot retain or hold iron. That is why in sandy soil, leaching of potassium is more. Then excess of P adversely affect utilization of. When we apply phosphorus in excess amount, so which nutrient availability becomes poor to the plant? So, there is an antagonistic relationship between phosphorus and zinc. So, whenever we apply the phosphorus amount, then zinc absorption is reduced. When we apply the zinc, then phosphorus is reduced. So, there is a compound zinc phosphate compound and it is insoluble compound. So, that is why there is a negative relationship between phosphorus and zinc. Interaction between lime and iron is. So, iron is available at low acidic pH. Whenever pH is less than 7, then availability of iron is more. Actually, metallic cations are available at low pH. Zinc, manganese, copper, iron, these are available at low pH when pH is less than 7. And lime tends to increase the pH because of calcium. So, when we apply the lime, then pH gets high and it becomes above 7, and then in this case when pH becomes above more than 7, then availability of iron is reduced. It means application of lime increases the pH and then availability of iron reduced. So, this relationship is negative relationship. Okay. Next is plant utilize nitrogen, inorganic form, organic or both form or amide form. Okay. So, actually nutrients are used in inorganic form. Whatever nutrient is there, they are absorbed in inorganic form, and that is why iron are called inorganic form. So, not only nitrogen, other nutrients are absorbed by the plant in inorganic form by the from the soil. And in phosphorus cycle, the phosphorus is not involved in any exchange process with the. There is phosphorus cycle, so which is not involved in phosphorus cycle? Plant, soil, microorganism. Definitely phosphorus is present in soil and plant absorb, so soil and plant is in phosphorus cycle. And microorganisms are involved in phosphorus solubilization. They solubilize the fixed phosphorus, so microorganisms are also involved. But atmosphere is not involved in phosphorus cycle. But in case of nitrogen cycle, atmosphere is involved. The available potassium is, available potassium means the potassium which is available to plant. Okay. So, in this case available potassium is both, which is present in solution as well as at exchange complex. Both form are available to plant, that is why available potassium is considered as both solution and exchangeable potassium. Next, the correct sequence of transformation of organic form of nitrogen to mineral form is, when there is a organic matter mineralization, then there is a sequence. Then in this sequence nitrogen is released. First organic matter is decomposed, amines are formed, then amines converted into ammonium and ammonium is converted into nitrate, and this sequence is aminization process of amines, then ammonification, ammonium ion is formed, then nitrification, nitrate ions are formed. So, correct sequence is aminization, NH2 group is formed, ammonification, NH4 is formed, then nitrification, NO3 is formed. Deficiency of calcium and magnesium most commonly occur in. Actually, calcium and magnesium are available at high pH. Whenever condition which favor the high pH will lead to more availability of calcium and magnesium. Whenever pH is less than 7, then there is a deficiency of calcium and magnesium. So, in this case low rainfall area, leaching is there, okay. Leaching there and acidity is created, then coarse textured soil, CEC is less, high pH soil, calcium and magnesium is available, and all of these. So, correct answer is coarse textured soil. In case of coarse textured soil, they are not able to retain the ions, that is why deficiency is there. And low rainfall is there, so it means leaching is less. If high rainfall is there, then leaching will be high, then calcium and magnesium will be deficient. But here is low rainfall, so leaching is not there. But in coarse textured soil, CEC is less, so chances of leaching are more, that is why deficiency of calcium and magnesium. And high pH, calcium and magnesium are available at high pH, that is why no question of deficiency of calcium and magnesium at high pH. Soil usually contain less magnesium than calcium because. So, in soil magnesium availability or we can say soil retention power towards magnesium is less when we compare with the calcium. The reason is that magnesium ions are not absorbed as strongly by clay and organic matter as calcium ion. So, organic matter and clay have cation exchange sites where cations are held, but calcium has more binding capacity as compared to magnesium. It has more bonding strength. So, when there is a competition, calcium get site on exchange and it get exchange site on clay and organic matter, and magnesium remain in soil solution and then leach down. Then magnesium ions are more susceptible to leaching than calcium ion, because calcium occupy the space or exchange site on calcium and organic matter, and magnesium in soil solution. So, more chances of leaching. That is why both options are correct and above both. Sulfur-oxidizing bacteria belongs to genus. Sulfur means thio. Whenever sulfur, thio is related with the sulfur. That is why thiobacillus is correct answer. So, whenever there is thio, it means there is sulfur. Which micronutrient deficiency is found in all the soils of agroecological regions of the country? The most abundant or most occurring micronutrient deficiency in our country is zinc. So, zinc is the most abundant or occurring deficient nutrient in our country. Which one is not a cause of soil acidity? Means which factor does not contribute in soil acidity? Whenever there is high rainfall, leaching of base forming cation calcium and magnesium. When there is leaching of calcium magnesium, pH decreases, because there is deficiency of calcium and magnesium. Leaching of appreciable amount of calcium and magnesium, this is true. This also contribute in soil acidity. Then buildup of hydrogen and aluminum species. Hydrogen and aluminum contribute in acidity. So, high rainfall is also responsible for acidity because of leaching of this nutrient, and hydrogen itself create acidity, aluminum also create acidity. So, all these contribute in acidity, and question is asked about one is not a cause of soil acidity. So, answer is none of these, because all these three contribute in soil acidity. Which one grow well under very acid soil? So, there are many microorganisms, and every microorganism require a particular pH for their growth, and under acidic condition fungi grow well, and neutral pH bacteria, and slightly higher pH actinomycetes. So, in this question answer is fungi. Fungi grow well under acidic condition. So, whenever soils are acidic and crop are subjected to fungi, we try to increase the pH so that fungal infection become less. Agriculture lime is different type: calcium oxide, calcium hydroxide, calcium carbonate, and dolomite is calcium carbonate plus magnesium carbonate. This combination, and agriculture lime is lime carbonate. Calcium carbonate is termed as agriculture lime. So, there is a confusion, and we have to remember. We should remember what is agriculture lime. It is calcium carbonate. Calcareous soils are those that contain enough free. Calcareous word is related with the calcium carbonate. So, these are different: calcium, sodium, potassium, magnesium, all these three are base forming cation, but calcareous is related with the calcium carbonate. Okay. Then soil electrical conductivity is measure of. So, what parameter is measured by electrical conductivity? Okay, and electrical conductivity measure total salt. How much salt is present in water, how much salt is present in soil is measured by electrical conductivity, because this electrical conductivity or electrical current, we can say, it is carried by ions. So, that is why if salts are present, definitely salts are formed of ion, and these ion carry currents. That is why electrical conductivity EC is a measure of total salt. If EC of soil is very high, it means salt content is very high. If EC is low, then salt content is low. So, EC and total salt is directly related. Then diagnosis and recommendation integrated system is a new approach. Why we use DRIS? Okay, to know nutrient balance in soil, imbalance, interpreted leaf or plant analysis, soil salinity measurement, or identifying insect and disease infection. So, this DRIS approach is very important approach, and it is used to interpret leaf or plant analysis. We analysis the leaf or plant which nutrient is deficient, Okay, there is a leaf analysis, and then accordingly we apply the nutrient. That's why it is known as diagnosis of nutrient deficiency. Then recommendation, how much nutrient we should apply to correct the nutrient deficiency. It is known as diagnosis and recommendation integrated system, and it is related to interpreted leaf or plant analysis with respect to its nutrient content. So this was about the mock test of soil fertility. Thank you very much.